All right, welcome everyone to this fourth video talking about acids and bases. Okay, so far we've kind of discussed what is an acid, what is a base, right? These acid bases, equilibrium reactions, right? pHs, pH scale, conjugate acid-base pairs, all these things, right? So now we're going to start talking about, for acids and bases, what are considered strong acids, what are considered weak acids, and strong bases and weak bases. Okay, so in this video we're going to focus on strong acids and strong bases. Okay, so what is a strong acid? Okay, well, a strong acid is something that fully dissociates. Okay, so 100% dissociation, meaning if I put HCl in solution, HCl will fully break apart in H plus Cl minus. Okay, this is a unidirectional thing, right? This goes all to products, right? 100% dissociation, right? HClO3 breaks apart, H plus ClO3 minus, okay? So the hydrogen completely breaks off for every single molecule, and you get full 100% dissociation in a strong acid, right? Now, the only acid I'll also mention here, right, for H2SO4, only one hydrogen fully breaks apart. So you're left with HSO4 minus, okay? So this reaction is considered a strong acid reaction, right? This H2SO4 is a strong acid, and it removes only one hydrogen for that strong acid kind of reaction, if you will, okay? Not both, okay? And we'll talk more about polyprotic acids in a future video, okay? But here, just note H2SO4 is a strong acid, but only donates one proton as a strong acid, okay? But again, 100% dissociation, so what that means is the concentration of H plus ions in the solution is just equal to the concentration of your acid, okay? So concentration, if I have a solution of 0.1 molar HCl, okay, that tells me I have a solution of 0.1 molar H plus ions, okay? Right, which has a pH equal to 1, okay? That's what that tells me, right? Right, and that's only true for strong acids, that they fully break apart, and the concentration of hydrogen ions is just equal to concentration of acid, okay? And listed here in this slide is our list of all possible strong acids that we will talk about in this class, okay? Right, and so memorize this list, because I promise you there are a lot more weak acids than there are strong, okay? So you don't want to try to remember what are all the weak acids, okay? If an acid is not on the list given in this slide, it is not a strong acid, okay? So just memorize these guys: HCl, HBr, HI, HNO3, HClO3, HClO4, and H2SO4. Those are your strong acids. Keep them in mind, right? So whenever you have a problem, you can easily identify, oh, this is a strong acid, so I treat it and use it like this in the problem, right? Or this is a weak acid because it's not on this list, okay? Right. So briefly talk about kind of ideas of superacids. Okay. So all the acids and bases we'll do in this class are acid-base reactions that take place in solution with solvent as water. Okay. Well, that solvent being water, okay, means that you've essentially limited the strength of that acid. Okay. So things like hydrofluoric acid in water is not really a strong acid. Hydrofluoric acid, like as a liquid itself, is a very strong acid, right? Okay. And if you mix hydrofluoric acid with SBF 5, okay, have a solution of that, okay, that forms a solution which is considered like a superacid. Okay, it's considered a superacid because it's like 10 to the 16 times stronger than one of the strongest acids in water available to us. Okay, H2SO4 is an extremely strong acid. Okay, so it's an acid that makes up acidic rain, right? And it is extremely weak compared to this, say, superacid solution given here, right? In gas phase, you have, say, HeH plus is considered a superacid, which has a strength of 10 to the 60 times greater than H2SO4. Okay, so these superacids, right, only exist outside of water solutions. okay, and are used in certain applications in chemistry, chemical reactions, or things like that, but are very, very dangerous. Okay. Okay. And then the last thing we'll talk about this video are strong bases. Okay. Our strong bases consist of our group 1 hydroxides, okay, and our group 2 hydroxides, so your alkali and alkali earth metals, okay, so sodium hydroxide, potassium hydroxide, so on and so forth, right, calcium hydroxide, barium hydroxide, strontium hydroxide, right, these are your strong bases, okay, right, they again are considered a strong base because they fully dissociate, okay, but note here that your group 1 hydroxides, okay, those all fully dissociate into one OH minus ion, right? But your group 2 hydroxides dissociate into 2 hydroxide ions, so you get 2 OH minus, okay? So for the group 1s, the concentration of OH is equal to the concentration of the sodium hydroxide, but for calcium hydroxide, concentration of OH minus is 2 times the concentration of calcium hydroxide, right? So if I have 1 molar calcium hydroxide, that means I have 2 molar hydroxide ions, right? Note here, right, that I should note, right, that all group 1 hydroxides are strong bases, but not all group 2 hydroxides. So, okay, so listed here are the strong base group 2 hydroxides that we deal with in this class, okay? So again, remember what these strong bases are, because everything else is considered a weak base.